press again. All right. So guys, it's page 221. Okay. 10 P's are generated so that there's a 75% chance that an individual P will have a green pod. Okay, so already I'm just deeply interested in this problem. Find the probability that among the 10 P's, at least 9 have green pods. All right, so let's break this down. There's discussion about P's and pods and all that stuff, but what's the real important thing here? I've got, what's the probability that it's a green pod? What's that probability? 0.75. So they tell me that directly. Right? So what would that be in this problem? What variable would that go in for? Careful, what would n be? Did you say that? Look. Yeah, that would be p. What would n be for this problem? All right, I like that. We got competition. So we got n is always got to be the total number. And in this case, I want 9 successes, right? Good. So there's 10 total that I'm looking at. And I want how many successes? 9 or 8. Careful. So we'll figure out in a second. So what is the question? Find probability that I'm on at least 9. So probability that x is how related to 9? At least 9 would be greater than equal to 9. 11. So that's what I'm saying. Be careful here. What's greater than equal to 9? 9 or 10. Cool. So whenever you see an inequality statement, at least, more than, something like that, it's probably going to involve either 1 minus none kind of thing, or you have to do several calculations, right? Now, how many calculations do I actually have to do directly to answer this? We just said 2, right? I have to do 9 and 10. The opposite of this would be less than 9. That would be 0, 1, 2, 3, 4. Oh, screw the opposite. The opposite would be more work. So I'm just going to do exactly what they asked me to. 9 and 10. So it could be 9 P's that are green or 10 P's that have green pod. But do you see the steps I had to take to interpret the question the way that it was given to me? It was given to me in English, and I had to turn it into mathish, right? So this is writing what they told me, using the symbols that I know I need. P is success, N is the total number, X is the number of successes. What else am I still missing though? Q would be 0.25. The rest. Cool. So how would you set up that first one? The probability X equals 9. If you do this in parts here. What would that look like from the formula? 10. I've got 10 total things I'm looking at. I want to choose 9 of them, of course, right? So how many successes do you have? 9. I don't want them all to be green. I just want 9 of them to be green. So how many failures do you have? 1. You can plug that in your calculator. Everybody remember how to get to this choose? Choose is NCR is math, probability, and I think it's number 3. I can't remember. I think it was number 3 or 4. So that's how you get to that. And the reason, somebody pointed out the book has this complicated formula for it. Bless you. And it is the formula for it. But it doesn't really help us conceptually with anything else. All I care about is the fact that it counts how long the list would be. So let's see if we all get the same answer here, for those of you playing along. What'd you get now? Sorry? 0.1877, blah, blah, blah. Let's say roughly that. All right, so it's approximately that. And now you just figure out for 10, you set up the formula again. And I hope to God, at this point, most of you guys realize this formula is really crazy easy. Here I got 10 total things. I want to choose 9 of them to do something. So 9 of them do this, and the rest of them do that. The formula sets itself up. Can't beat that. So to finish this problem out, which I won't do that one, same way, and then add the two together, because you could do it this way or that way. And or means add. Okay. Is that good? Or who asked that question? Is that all right?
Yeah. So before like the 0.25, you just raise it to 0 power?
Exactly. For the next one, I want 10 successes now, right? Which means how many failures? None. I want them all to be green, none of them not green. All right? Okay. Any other questions from homework? Okay. A quick little thing. If somebody claimed that they can make 75% green pea pods, right? And I was somebody that was really interested in that claim. If I wanted to check their claim out to see if they were a liar, one direct way I could do it is, let's say I take 40 pea pods, right? Can somebody tell me what's the average number of pea pods, otherwise known as the expected value of pea pods that should be green? How would I find that out?
20.
Careful. What's the expected value also known as? Average. I love it, right? Expected value. Why do they call it that? Because whatever your average is, you expect it over the long run, that's what you're going to make. That's what you're going to get, right? So how many pea pods would you expect out of 40 that would be green? What percentage are green? 75%, right? So it's just the best little formula for mean yet. N times P. If you expect 75% to be green and you got 40 of them, it only makes sense if you expect 75% of 40 to be green. That's basically what they just said. 75% of them should be green. So if I take 40 pea pods, how many should I see that are green? 30. 3/4 of 40, right? So I should see 30. Give or take, how can I figure out how much I should give and take? I mean, if I got 29, that really should be all right. I wouldn't go, you liar, right? Because, controversy builds. Pea pods are a very heavy controversial issue. But 29 would be all right. Well, where's it stop being all right? How do I figure out those levels? Where does it stop being okay?
Outside standard deviation.
Exactly. That's the min and max value, right? So section 5.5. If you haven't done this homework yet, was it 5.5 yet? Or 5.4, sorry. Section 5.4 is just all about finding the mean, finding the standard deviation, and then seeing what's min and max usual. And then they'll say, well, is this unusual? And you just say, is it between these two or not? You can't beat that. That homework should be pretty straightforward. How do I find the standard deviation here?
N times P.
And take the... Cool, so somebody help me out. That would be 0.75 times 40 times 0.25. 1/4 of 30 is 7.5 squared. That would be 2.6, I don't know. Is it 2.718?
2.74.
Wait, really?
2.738.
2.738. All right, I was off by 0.02. It's not bad.
So we say that's 2.74.
You guys doing okay so far? You cannot beat those four formulas, especially compared to some of the other things we've done in this class. Why are these the easiest formulas ever? Because I got one probability, P, right? And I got a no, I mean, it should be. The x p of x, I got a bunch of p of x's. I should expect it to be kind of ugly, right? And if I just get a list of data points, I've got to add them all up, divide by the number. That's, it's going to involve a little bit more. So how do I find the minimum usual value? What's the minimum?
30 minus.
Multiply that by 2.
Yeah, 30 minus twice this. Like 24.5 something. I don't know. So it's about 24 and a half. And then the maximum value, I'd expect 30 plus that. And that, of course, should be about 35 and a half roughly.
35.47.
So really roughly, right? So if I did take 40 randomly selected pea pods from this dude's place, and I found 10 of them that were green, what would that mean? That's unusual. So either, now here's the thing, this is the trick with statistics, and this is going to help us out in some very soon to be done sections. The difference between I just did something really unusual versus I think this guy's lying, right? So if I got 10, what was the smallest amount I would expect? 24 and a half, right? So like 24 maybe I could take. If I got 24, I go, you're right on the edge. But technically I'd have to say that's unusual, right? But I got 10. That's stupid unusual. And later, you'll see that one thing that's missing out of this to really be truly technical is figuring out a z-score for this, right? We can figure out the z-score from this actually if we wanted to, but 10 is way far away from what's usual. In fact, if I did find a z-score, how many steps away from 30 is 10? Is 20 divided by this is like 6 point something. That's the z-score. That's way out there. So what's that mean more likely? Is it impossible that I would have done that if he was telling the truth? It's not impossible, but it's stupid unlikely. If he's telling the truth, I did something that is crazy unlikely. So what's more probable? That he's lying, right? That's going to be so important later. We want to be able to test people's claims. And this is important. This is Consumer Reports. This is all this stuff. How do they test? How do they know when they see something? They just do it several times. How do they know they're right? Well, they don't. They do it with probability. Okay, maybe. So all 5.5 is going to have you do is this. 5.5 says find these, and then find these. And then they ask you, is this usual or not? Right? So 5.5 should be pretty straightforward. So let's get into 6. Any other questions left over? Or? All right, so I'm going to do a real quick review of 6, and then I'm going to have you guys do a few problems out of the homework, and probably just number 4 here too from that handout from last time. So the main thing to realize, so often in math, the nuts and bolts of doing something is easy. The concept behind it is hard. So I hope I made some sense when I was trying to show you the connection between this and this. The fact that the probability here is related to the area, and so is it there. Anytime you show a probability distribution